Jupiter was never supposed to be this complicated. A giant world made mostly of gas, governed by gravity, pressure, and rotation. No surface, no solid ground, just layers compressing deeper and deeper into extreme conditions. For a long time, that model worked, until we started looking closer. When Juno arrived at Jupiter in 2016, it wasn't there to take pictures. It was there to measure what we couldn't see: gravity, magnetic fields, internal structure. And almost immediately, something didn't add up. The data coming back wasn't clean. It wasn't consistent with the models scientists had trusted for decades. Instead, it suggested something far more complex and far more unsettling. Jupiter's interior was expected to have a defined core, a dense, compact region formed during the planet's creation. But Juno didn't find that. What it found instead was blurred. A massive, diffuse region where heavy elements are mixed throughout the interior, extending far beyond where a solid core should exist. A fuzzy core. Not solid, not clearly defined, almost as if something had disrupted it long ago, and it never fully settled again. This alone was enough to challenge decades of planetary science. But it wasn't the only anomaly, because as Juno continued its passes over the planet, it began detecting variations in Jupiter's gravity, small differences, subtle but measurable. These variations suggested that mass inside the planet wasn't evenly distributed, that something within Jupiter was moving, shifting, changing over time. This wasn't a static world, it was dynamic. And then came the magnetic field. Jupiter's magnetic field is the strongest of any planet in the solar system. That part was expected. What wasn't expected was how irregular it is. Instead of being smooth and evenly shaped like a simple dipole, Jupiter's magnetic field is distorted, lopsided, compressed in some regions, stretched in others. There is even an area known as the Great Blue Spot, a region where the magnetic field is significantly stronger and behaves differently than the rest. This kind of asymmetry suggests something unusual is happening deep inside the planet, something affecting how the magnetic field is generated. Magnetic fields are created by motion, in Jupiter's case, by the movement of metallic hydrogen, a state of matter formed under extreme pressure where hydrogen behaves like an electrical conductor. For the magnetic field to look the way it does, that movement cannot be uniform. It must be uneven, disturbed, driven by processes we don't fully understand. Then came another discovery, one that changed how we think about Jupiter's atmosphere. For a long time, scientists believed the colorful bands and storms we see were shallow, surface-level phenomena extending only a small distance into the planet. Juno proved otherwise. Those atmospheric bands extend thousands of kilometers deep into Jupiter's interior, far deeper than expected. This means the weather we see is not just surface activity. It is connected to the planet's internal structure, driven by forces that originate far below the clouds. And the deeper we look, the stranger it becomes. Because Jupiter doesn't rotate as a single solid body. Different regions rotate at different speeds. The equator moves faster than the poles. Internal layers may be rotating differently from the outer atmosphere. This differential rotation creates shear forces, instabilities, energy transfers that ripple through the planet, and those effects don't stay contained. They rise. They distort the atmosphere. They influence the magnetic field. Everything is connected. But perhaps the most unsettling discovery is that Jupiter may not be as stable as we once believed. The internal structure, the magnetic field, the atmospheric depth, all of it points to a planet that is still evolving, not dramatically, not visibly, but continuously. Some scientists now believe that Jupiter's fuzzy core could be the result of a massive collision early in its history. A planetary embryo, possibly several times the mass of Earth, slamming into Jupiter while it was still forming. Instead of destroying the planet, the impact would have mixed its interior, disrupting the core, spreading heavy elements outward, and leaving behind the structure we see today. If that's true, then Jupiter carries the evidence of a violent past hidden deep inside it, a past we can't see directly, but can only infer from the way the planet behaves. And yet, even with all this new understanding, there are still things that don't fully make sense, because some of the changes Juno has detected suggest that Jupiter's interior is not just complex, it is active, still shifting, still responding to forces we have yet to fully map. Which leads to a deeper question. Are we looking at a planet that has already formed, or one that is still in the process of becoming something else? Because if the core is not stable, if the magnetic field is irregular, if the atmosphere is deeply connected to internal motion, then Jupiter is not just a giant gas planet, it is a system in motion. A world where the boundary between interior and exterior doesn't truly exist. And if something strange is happening inside Jupiter, we may only be seeing the surface effects, the visible symptoms of processes occurring thousands of kilometers below, in a region we cannot directly observe. Because the real story of Jupiter is not written in its storms, it is written in its depths, and what's happening down there may be far more complex than anything we expected. What Juno revealed wasn't a finished picture, it was a crack in the model, because once you accept that Jupiter's core is not solid, that its gravity is uneven, that its magnetic field is distorted, you're forced to accept something else. The interior is not stable, it is moving. Deep inside Jupiter, pressure climbs to levels that don't exist anywhere on Earth. Hydrogen, the simplest element in the universe, is pushed into a state that defies intuition. It becomes metallic, not a gas, not a liquid in the normal sense, but a conductive fluid, capable of carrying electrical currents. This is where Jupiter's magnetic field is born. But for that field to look the way it does, uneven, distorted, stronger in some regions, the movement of this metallic hydrogen cannot be smooth. It must be turbulent, chaotic currents flowing in patterns we don't yet fully understand. Juno's measurements suggest that this metallic region does not behave like a simple rotating layer. Instead, it may be interacting with the overlying atmosphere, and even with the fuzzy core itself. This creates a feedback system. Energy moves upward, motion transfers outward, and what begins deep inside the planet eventually reshapes what we see on the surface. Only of the most puzzling aspects of Jupiter is its energy output. It emits more heat than it receives from the sun. That shouldn't happen, at least not in a simple system. The excess energy is believed to come from internal processes, gravitational compression, slow contraction, and possibly differentiation within its interior, where heavier elements sink and release heat as they move. But even these explanations don't fully account for the amount of energy observed, which suggests something else may be contributing, something deeper. This excess heat drives convection, massive currents rising through the planet's interior, carrying energy upward. These currents don't move in neat, symmetrical patterns. They twist, they collide, they break apart and reform. And as they reach higher layers, they influence the atmosphere. The bands we see on Jupiter, the light and dark stripes, are not just surface features. They are the visible expression of deep internal motion, thousands of kilometers deep. This means Jupiter's weather is not separate from its interior. It is an extension of it. The storms, the winds, even the long-lived Great Red Spot, all of it is connected to processes happening far below, and those processes are not uniform. Jupiter rotates rapidly, completing a full spin in about 10 hours. But it doesn't rotate as a single unit. Different latitudes move at different speeds. Internal layers may rotate differently from the outer atmosphere. This differential rotation creates shear forces. Energy builds where layers interact. Instabilities form, and those instabilities can travel, rising through the planet like waves. Some of these waves may be responsible for the irregularities in Jupiter's magnetic field. Others may influence the distribution of mass inside the planet, and some may never reach the surface at all. This raises an unsettling possibility. There may be entire layers of activity inside Jupiter that we cannot detect directly. Hidden systems of motion, operating beneath the limits of our instruments. The idea of Jupiter as a simple gas giant no longer holds. It is not a uniform sphere. It is not a stable structure. It is a dynamic system with multiple interacting layers, each influencing the others. And then there is the question of time. Jupiter is over 4.5 billion years old. For most of that time, it has been slowly cooling, slowly contracting, but that process is not complete. Even now, the planet is still releasing energy from its formation, still shifting internally, still evolving. If the fuzzy core is the result of an ancient collision, then the effects of that event are still present today, still shaping the planet's structure, still influencing how energy moves through it. This means that Jupiter's current state is not just the result of slow evolution, it is the result of history, a record of events that occurred billions of years ago, still visible in the way the planet behaves now. And yet, even with everything Juno has revealed, we are still only observing indirectly. We cannot see inside Jupiter. We cannot measure its core directly. We rely on gravity, magnetism, and models to infer what lies beneath. And those models are still incomplete, which leads to a final realization. Jupiter is not just hiding details, it is hiding entire processes. What we see, the clouds, the storms, the bands, is only the outermost layer of a system that extends tens of thousands of kilometers below. A system driven by forces we are still trying to understand. And if something strange is happening inside Jupiter, it may not be a single anomaly. It may be the natural result of a planet that is far more complex than we ever imagined. Because in the end, Jupiter is not just a planet, it is a reminder that even in our own solar system, there are worlds we do not fully understand. Worlds that continue to evolve, to change, to challenge the models we build to explain them. And somewhere deep inside Jupiter, beneath layers of metallic hydrogen and crushing pressure, the processes that shape it are still unfolding, quietly, relentlessly, and far beyond our reach.